everybody. Welcome to today's webinar presentation hosted by IEEE Standards Association and ICAP. My name is Tyler Jones-Champion. I am your event producer for the session and your MC for today's webinar presentation on the topic of IEEE Test and Certification, Advancing the Grid Toward Trustworthy Time. At this time, I would like to welcome all of our participants from all over the world today. We really appreciate you being with us. Before we start, I just want to go over a couple of housekeeping items as we traditionally do with all of our webinars. First, if you join today listening through your computer speaker system, also known as VoIP, this means you will be able to hear the entire presentation without having to dial in using a telephone. At the end of the presentation, speakers will be taking questions from you, the audience. You have the ability to ask our guest speakers a question in the WebEx chat feature, which is located in the upper right-hand pane in your WebEx window. Simply type in your question to Brett Haziel. He is located there in the panelist section, and then click the send button. We will get to many of them as we can today. I also want to let you know we are recording today's webinar, so if you miss a portion of the session or you simply would like to share it or watch it on demand, we will follow up with you to let you know where you can find the video and as well as the slides. At this time, let's go ahead and get started. I'm going to now kick it over to Jason Alnut from IEEE Standards Association and let him introduce our speakers. Thank you.
Oh, thank you so much, Tyler, and thank you everybody who is on the line and took the time to hear about this effort that IEEE has been working on for some time now. My name is Jason Allnut. I'm the IEEE Conformity Assessment Program Manager for this program. On the screen here, you'll see our agenda. We have three distinct presenters here who are going to give you a lot more information, but just so that everybody is aware of what we're talking about here, the C37.238 standard that was recently revised and came out last month is a IEEE 1588 precision time protocol standard for power systems applications. This applies to things such as system protection, control, automation, and data communication. The C37.238 standard specifies a well-defined subset of IEEE 1588 mechanisms and settings that enable device interoperability, robust response to network failures, and other things such as that. All of the presenters here will give you a little more insight to that. But our conformity assessment program, which has to do with the standard, obviously, is what we're here to talk about and why device certification is so important. On the screen here, you can see our three presenters. We're first going to start with Koen Nguyen from NIST. He actually leads the Smart Grid Testing and Certification Project in the Smart Grid and Cyber Physical Systems Programs Office at the Engineering Laboratories. He's also a very active member in the Smart Grid Advisory Committee, Smart Electric Power Alliance, SEPA, which some of you may be aware of and maybe attended the Grid Evolution Summit last week. Next, Bob Noseworthy, who is the Chief Engineer at UNH-IOL. He has been very pivotal in this effort as far as authoring the TSS that our conformity assessment program uses in certifying products, and he's going to give you a little bit more insight on that. And then finally, Aaron Martin, who is with BPA, is going to give you a look at why timing is so necessary on the grid and what end users can come to expect by ensuring accurate time on the grid. So with that being said, I don't want to delay any further. I will be on the line and helping facilitate the question and answers portion at the end, as well as my email in case anyone would like to reach out and learn more about this conformity assessment program that IEEE is developing. So with that being said, Koen, if you want to get started. And
thank you, Jason, for the introduction, and good afternoon or good morning wherever you guys are, and thank you for joining the webinar today. So I'm Koen Nguyen from NIST. I'm going to talk a little bit about introduction to NIST, and also talk about why we believe that testing is important, and then cover a little bit information on the ICAP and then the conformity assessment program that we're discussing today. So NIST is the non-regulatory agency within the Department of Commerce. We're the National Metrology Institute for the U.S. We have two main campuses, one in Gaithersburg, where I'm at, and one in Boulder, Colorado. So our main mission is threefold, to focus on measurement science, standard, and technology in order to promote U.S. innovation and industrial competitiveness. So why is testing important? We believe that, testing gives confidence to the market and also to ensure that buyers are able to assure that the product that they procure actually, live up to the claim of the manufacturer, both for conformant and interoperability. And then the test result provide a good basis for standard development because the life cycle of the standard development testing provide, feedback on any ambiguity or gaps. And then the last point is to support the market in the continued innovation and evolution of the requirements. So wanted to touch on the difference between conformance and interoperability. Conformant testing is to test for if the product is conformed to either a specification or a standard, whereas interoperability testing, you do the test for different products from different vendors and see if they can actually interoperate with each other within a system. So the conformant testing does not guarantee interoperability, but it does, improve its chances of being interoperable, and we believe that both type of testing are needed. So here's our basic flow for what we believe this market test and certification landscape should be. So we start with the standard and specification, and then we develop different test artifact and different testing to actually build an ecosystem. So the central piece of today's presentation is on the test suite specification, which is within the certification test part of this ecosystem. So our main motivation for pushing more test program development and formation for smart grid is that we had conducted a landscape analysis on existing smart grid standard based on the NIST smart grid interoperability framework. We had a list of smart grid standard, and based on that, we found that not that many smart grid test programs are available for these standards. So we wanted to push more creation of test program in order to support the smart grid industry. So our work for test program development include, we do collaborate with industry to accelerate test program development, such as this particular one that we're talking about. So our work is through supporting the technical underpinning for the test by either develop test cases or test specs and things like that. We also participate in PlugFest and interoperability test event. And the final piece is to build awareness and encourage adoption of test program in order to further build the ecosystem. So the IEEE Conformity Assessment Program is actually a very nice addition to the whole spectrum of IEEE's services, where the standard development is one piece, but you need to have the verification at the end to make sure that you have the standard implementation according to the spec, and then that actually feedback to the whole standard cycle. So this is a very nice cycle that IEEE have put together to ensure that they have a robust standard development process. So for the 1598 Power Profile Conformant Assessment Program, we have formed a Conformity Assessment Steering Group, or the CAS, which include a lot of this stakeholders that are either using or testing the 1588 Power Profile. And the reason for the formation of this is we wanted to have a body to continue to work on the TSS and the test program as the standards are being revised, as requirements are being updated. So we want to have a a permanent type of body to actually continue to monitor and work on the program. And we have a base membership for the program right now, but we'll have some additional membership registration that will be opened up in the fall. So you just have to stay tuned for that. So with that, I'm going to turn it over to both Noteworthy from UNH-IOL to talk more about the TSS development. Thank you.
Thank you, Cho. And I am Bob Noteworthy. I'm the Chief Engineer at the Interoperability Lab at the University of New Hampshire. And I'll be speaking briefly to the program here and the TSS and our next steps before we pass it on to Aaron from BPA to give you his end-user perspective. First, a brief background on the IOL. My own involvement here has been with 20-plus years in the Ethernet industry, and most recently in the PTP space, certifying for the Avenue Alliance, the 802.1as GPTP standard, and really building from that experience and our Ethernet experience, we've been tapped with support from NIST for the past several years on various aspects of developing the TSS and the capabilities to support this program. So briefly, the University of New Hampshire, you may know, is just north of Boston, but you might not think of the University of New Hampshire for network testing, when in fact we have been in existence for nearly 30 years as the Interoperability Lab, providing the industry from Ethernet through all sorts of technologies, ATM, token ring, to today's technologies of IPv6, various wireless storage and related areas, and most recently time-sensitive networking and areas such as 1588 and the power profile. We're 100% industry funded and heavily student powered. We engage closely with standards groups like the IEEE, supporters of standards like NIST, developers who manufacture products, media, semiconductors, and products, all of the above, and end users such as BPA as far as meeting their needs and adjusting testing accordingly. It is an important process to recognize, as Kuhn mentioned, that standards, once they're developed, we may begin testing for those standard requirements. We may work with tool vendors to implement those tests, execute tests, and through the process, develop understandings where maybe the standard led to ambiguity or gaps in specification. And it's an important cycle to be aware of, that all elements are in play here when we're looking at developing a certification program. To repeat points made earlier, I think it is important to stress that conformance and interoperability are both an important aspect of the endeavor. We are the Interoperability Lab, but 90% of our work is actually focused on conformance testing, as this helps predict future interoperability testing, whereas interoperability tests at PlugFests or other venues help demonstrate current interoperability and perhaps help identify gaps in coverage. So we'll quickly look at the structure of the TSS from the 1588 Power Profile program here, but at a very high level, we're looking at the PTP framing of PTP attributes for management, P-delay mechanisms, BMCA, transport issues, timescale tests, TLVs of various forms, time and accuracy transfer, an important part of the Power Profile specification, and other optional features such as VLANs. If they're used, they should be used properly, that sort of thing. So here we have just a generic test format, and the details here I won't dwell on, but the purpose of this slide is really to impart, we aren't focusing the tests on a particular tool supplier. This is not a tool from UNH-IOL, it's not a tool from any one particular provider. Any party should be able to follow the generic abstract test here, follow the steps, and be able to implement the program. To that point, the procedures are abstracted away from step-by-step guides to how to execute a test so that, again, whether it's from company A, B, or C, the general process approved by the steering committee can be followed. Again, the details, whether it's a tickle script shown here or some other mechanism, should not be the focus. That is more for the tool providers to demonstrate that their tools support the test suite specification properly. So with that very quick high-level review of the TSS, we'll go through where we're at and what our next steps are. As we've explained, there's a steering committee, the task guiding the test suite specification, providing feedback, providing focus on areas and aspects of most importance from the developers and the end users perspective. There's a link here to take you to the 1588 page to tell you more about the state of the program as it evolves. And we're aiming for a certification program launch following a pilot phase. That pilot phase is planned for this fall, beginning in September. And following that pilot phase, possibly at the conclusion of the pilot phase, we expect there will be certifications issued to participants or those who participate in the program afterwards. I do want to invite folks to contact Jason or myself and the ICAP team at icap-team@IEEE.org for more information on how to participate in the pilot program. And as another step, we are continuing to work with parties such as NIST and test and measurement vendors such as CalNex, ICSIA, Spirent, and are certainly open to any other tool providers who may be able to help enable a more rigorous and robust and dynamic program where there's diversity and options for the participants, both to test in-house prior to pursuing certification at a test lab, or simply to give us the most robust solution. So again, I encourage folks to consider the pilot program if you're ready and to contact us to proceed. Going beyond just this initial phase of the conformance TSS, UNH-IOL will be continuing to work with NIST to develop an interoperability test plan. Much like previously alluded to, we want to ensure that there's some interesting tests that we can perform with real devices to help expose potential faults in the conformance tests, issues reported by end users, have a test bed that we can exercise against. And that's where stakeholders such as manufacturers and end users really need to have their input, and I look forward to that moving forward. But that element is not necessary for the upcoming certification. The upcoming certification is initially focused on conformance requirements. And going beyond that, we'll be looking at timing redundancy mechanisms, potentially security mechanisms, and essentially other needs as directed by NIST and the steering committee and others in the industry at large. So with that, I'll turn this over to Aaron from BPA to give us a use case study from the power industry perspective, and I thank you for your attention.
Thank you, Bob, and thank you for having me. I'm Aaron Martin with the Bonneville Power Administration, and I have a case study as how we apply the precise timing in the transmission system. What I'll be talking about today includes the background of our utility, some specific examples of applications that we use, examples of when timing has caused problems or inaccurate timing, and from an end user perspective, the benefits of participating in the ICAP program. So the Bonneville Power Administration has been around for over 80 years, and we service over 15,000 miles of transmission lines, primarily in the Pacific Northwest, covering states Washington, Oregon, Montana, Idaho, and we interconnect to California, Canada, and Wyoming. Most of our transmission includes 500 kV, 230 kV, and 115 kV with some various transmission levels in between, including one DC line of 1,000 kV. The power system transmission applications that we use for precise timing include PHASOR measurement units, line differential protection, traveling wave fault location, system event recordings, and substation local area networks. Now, first of all, what is a PMU? PMU is a synchrophasor or phasor measurement unit. It's a synchronized measurement of the system from a wide area that essentially tracks the power flow and the speed of the system, or what we call it, or the frequency of the system. And why is the 1 microsecond accuracy important? Well, the power system, North American power system that is running, it has a frequency of 60 hertz, which is pretty slow for most electrical application, but in our case, it's one period, or 360 degrees, is 16 milliseconds, and an accuracy of a quarter of a degree would be 11.5 microseconds. Now, Bonneville Power is part of the WISP, or the Western Interconnection Synchrophasor program. This is synchrophasors throughout the Western Interconnection grid, which is one of the phasor measurement units or data flows in North America under the NASB. So why PMUs? Why do we want to use PMUs? Well, it's a high-speed real-time data stream. 60 samples per second is what we get from our wide area PMUs, and synchronized is to combine the data is very important. It also provides a flexibility in the data stream. Not only do we get analog values from the data streams, we also get digital values of what's going on in the power grid. A good example of when I talk about measuring power between two areas is the phase angle. A normal phase angle between two areas within an interconnected system is 25 degrees. Using phasor measurement units in 2003, when that exceeded 25 degrees, you can see that around 1550 or 350 in the afternoon, the Cleveland system and the Western Michigan system begin to exceed that 25 degrees. Well, this was approximately 25 minutes, or 20 minutes before the system completely separated. With PMUs, it gives the operators a much more time to take action as the system fully separates. Most applications in the system are run with SCADA. Now, SCADA data, typically, at least at Bonneville Power, is data collected every 2 seconds. But with PMU's data, you can compare the accuracy of a SCADA data versus PMU data, and you'll see a much more concise power system flow, and where data can be missed or misrepresented with SCADA data. An example on the EPA PMU system with an abnormal angle occurred between Montana and Southern Oregon. Let's blow that up. And where the path between Southern Oregon began to exceed the system right about, this was in March of 2013. We could see the system getting a little too separated for us, and we were able to take action. Now, what's a frequency event? In this case, the Bonneville Power, we have a load break. We actually energize a 1,400 megawatt resistor to slow the system down. This is an example of what how much power would be used in a flux capacitor, let's say. From this, you can see that at these precise locations, go ahead and click through these locations. The blue location, which is Chief Joseph, where the load break is located. Red is in the Seattle area, green is in the Portland area, and black is in the Southern Oregon area at the end of our system. You can see the precise effect of the system being slowed down by that single load break using phasor measurement units. Going on to the next application, we used line differential relays. Line differential relays compare the magnitude and phase angles at two ends of the transmission line. Current in equal current out. And in that case, the current should be out of phase, or should be from one end 180 degrees out of phase with the remote end. During a fault condition, now the magnitude of the currents feed from both ends of the transmission line, feed the fault, and then the current generally goes to 90 degrees from both ends. This can be detected. Currently we use GPS to time sync the data streams between the two devices. The next type or application that we are starting to use is called traveling wave fault location. What exactly is a fault? Well, that's a fault. A fault is something that when the line actually goes to the ground and it must be cleared wide array. But during that time, when a fault occurs on a transmission system, next slide, it's very similar to a drop of a stone in a pond. There's waves that travel, high-frequency waves that travel throughout the power system in ever-increasing circles. Now, these waves generally travel at close to the speed of light and need to be sampled at 1.5 megahertz to capture these waves. But by doing that with precise timing, we can determine where the fault occurred by comparing at both ends of the line. Now, this is very important when you send a lineman out in the middle of the winter and you say, we've got a transmission that needs to be fixed, a transmission line that needs to be fixed. You don't want him spending 2 or 3 hours looking for that if he doesn't have to. It's dangerous and it makes the power system less reliable. If we can tell them, and we've been able to tell our linemen using this technology within a tower of where the fault occurred, is an actual recorded traveling wave event, a very high frequency event. Again, it was 1.5 megahertz that was copied. And this is just one end of the line. A slower accuracy requirement that we've been using is the digital, recording the digital events within a substation. For instance, we need to know at least within a millisecond of when a power circuit breaker interrupts the current, when the trip gets sent to the breaker. This tells us if the breaker is getting slow or if it didn't operate correctly or if circuits aren't working correctly. So every event that ever occurs, every fault that ever occurs is investigated to ensure, using these system event recordings to ensure the accuracy and the correct operation of the system occurred. New technologies such as the 61850 with boost messages or the 61850 with sampled values is requiring accuracy. Boost messages, which is generally digital messages, sometimes analog messages between devices within a control house of the substation, requires 1 millisecond accuracy. SMTP has been able to work with that, but it is not sufficient for the sample values of devices that collect analog data from the devices out in the yard, such as the current transformers or the potential transformers, the many sensors that all must be synced up. Those devices can be synced up with a 1 pulse per second locally, but you still need to get that accurate time to those devices. That's where C37.238 or 61859-3, the precision time protocol, will make things much more easy. In a substation, in particular a large substation, there's hundreds of data being sampled at very high rates that requires precise timing for the algorithms of IEDs to correctly operate. So it's very important that we have accurate time, not just over a wide area, but locally within a large substation. Now, going on to an example of when an unsynchronized timing causes an event. Back in March of 2014, the Air Force was conducting functional checks of space vehicle number 64. Well, this led to, we had a couple line differential relays, if you remember line differential relays, synchronized the current signals at both ends of the line using the GPS. Well, one of the relay's GPS receivers incorrectly logged onto this satellite that was under task mode. In this case, go ahead, next slide. In this case, it led to the data being between both ends of the line being unsynchronized. If you look at the top graph, that's a normal load operation. You have the currents from the local end, the remote end, the red and the black signals, being 180 degrees with a little differential. A little differential is normal with the line charging current of any transmission line. But when the one satellite incorrectly synchronized to the one GPS receiver, the differential relay is incorrectly synchronized to the satellite under test, it shifted the signals by 110 degrees out of phase with each other, or I guess it was 180 degrees, so it shifted it by 70 degrees, putting it at 110 degrees, creating a much larger differential current in here. And this caused not just one 500 kV transmission line to operate on our system, but two 500 kV transmission lines operated over the weekend. Another example of unsynchronized time occurred when the clock receiver, again, another clock receiver issue, lost GPS sync in March of 2015. During the event, there were multiple instances of multiple TMUs reporting that the sync was good, had been reestablished, and the status was good. So the clock was incorrectly saying, I have good data, meaning the end device did not just trusted that data. Now, a redundant system did not experience this problem. We are confident that there was a sync problem because suddenly the angles of the PMUs jumped by 40 degrees. This is shown in the next slide. There's the green slide is the angle jumping by 40 degrees. The next slide, or aqua blue, is good sync and then loss of sync and then good sync. And then right when it says it has good sync at the end of it, that's when the angle jumps. So clearly a problem with the timing data on the system. So what is the role of the IEEE Power Profile Committee Assessment? What does it mean to an end user like Honorable Power? Well, our group has been providing guidance towards the development of a test suite specification. We act as advisors in the development, the implementation, and operation of the Power Profile. So having a profile of a standard is very good, but certifying a profile such as this group is even better. It provides a lot more confidence for the end user. So why is that important? Well, this provides a direct collaboration between the end users, the certification groups, the standard authors, and manufacturers. It's a single place, not going to the authors or going to the manufacturers or going to the end users. You know, it's where everybody's kind of working together in one spot. And as a participating party, the standard authors and the certification group can identify gaps sooner. Vendors can work with the collective market being many utilities that participate, seeing what they need, and the end users see the results faster. Technology moves very faster. Improvements, adoption of technology needs to move faster for the adoption to move faster. Some of the things that I've seen over my career, the new technology gets developed, the standard is written, manufacturers adopt technology, the end user applies the technology, they identify gaps. They shy away because the gaps are too much for them to apply to the power system. The standard is rewritten. The market weakens during this time because not only have the utilities lost interest, but the manufacturers have lost interest because people can't use that technology. Remember, when you are updating the control system of a power grid, it's similar to, it's maybe not as dramatic, but imagine upgrading the controls of a plane in flight. The plane needs to be in the air the whole time you're doing it. So you have to have something that is very reliable. The technology you're applying needs to be, the power system needs to be on all the time. So why is ICAP important? It shrinks this process. Through the ICAP certification, it provides the confidence to all those involved, not just the utilities, not just the manufacturers, but the people that write the standards, the people that test the standards. It's a great place, it's a collaborative place for people to work together. So in conclusion, I talk about the BPA power system. Again, we are a wide area network, transmission network over the Pacific Northwest, part of the Western Electric Grid. We have a number of precise timing applications. I've mentioned events that show how unsynchronized time can affect the power system. Power systems such as ours cover large areas, and they require this accurate timing. And why an ICAP, especially that in timing precision, is very important to the life cycle to speed up the life cycle of a standard technology and adaptation. With that, are there any questions?
Yeah, and this is Jason again, just to open it up to everybody, and thank you, Aaron. Really appreciate the presentation, and then to both our presenters, Bob and Kuhn, thank you. I think there were some great visuals in there and some great information. I'd like to open it up to all the attendees if you have questions for any of the presenters about timing or about the 1588 power profile or this ICAP effort. Please feel free to use the chat feature or the question and answer feature to send them through. If you use the chat feature, please send them to Brett Housel, and he will get them out. We do have a couple questions already that I'd like to get the speakers' input on. And the first one is for you, Aaron. One of the attendees would like to know what type of entities is ICAP looking for as far as participating in the steering committee, and then how do they actually get involved?
Well, we're looking for utilities, manufacturers, all those involved in the power industry that will be applying this technology. The TASC is going to begin accepting new members this month. With more information, and a registration site will go out to anyone registered for this webinar when the slides are sent out. As far as the pilot test participants, we are looking for vendors to become members of the, specifically to the TASC, and then they'll be eligible for the pilot testing participation. Outside of that, please reach out to Jason, and we'll be able to provide more information.
Yes. Yeah. So, yeah, thank you, Aaron. That's correct. And just so everyone knows, Aaron is the chair of this Conformity Assessment Steering Committee that's leading this effort. But if anybody has any further questions about joining the steering committee or becoming a pilot participant, they can reach out to me. And then, Bob, just as a follow-up, there's a question here. Are there any vendors actually signed up for pilot testing at this point?
Yeah, we're a little bit early, as Aaron just alluded to. The registration site isn't quite up yet, but we have a link in the slide deck that will take you to the 1588 landing page from ICAP. From there, you'll be able to find the registration page when it is available. But so far, we do have at least 2 vendors who expressed a strong desire to participate with efforts underway to start getting us products in our lab, so that we can, sort of maybe get a pre-start, a pilot of the pilot, if you will. And we really are looking for at least 2 to 3 more participants. Obviously, as a pilot, we want to try to focus on validating the TSS itself, the test tools, for generating feedback for the steering committee's review. But certainly it'll be a happy problem if we have too many people trying to participate at this point. We're not looking for parties that have products that they believe are fully conformant. Any issues, any devices that might be conformant, for example, to the 2011 version of the power profile, would still be welcome, but obviously there'd be some noted issues between the earlier standard and the updated 2017 version.
Yes, thank you. Yes, absolutely. Okay, we'll keep moving along here because there's a few more coming in. I'd like to get to as many as possible. We have some time here, so I think we can answer quite a few of these questions. Aaron, I think this one might be for you, but obviously the other presenters can fill in afterwards. But is there any concern that timing could be spoofed for a critical application causing an incorrect response from the system?
Absolutely. Yes, that is that is a concern.
Yeah. And hopefully by, using the certification program and, our steering committee, we can address that and hopefully mitigate those issues in the future.
And just to add briefly to that, Jason, on slide 30, you don't need to go to it, but if the group refers to it later, I make mention of the 1588 revision effort, which is an update to that standard. As we sort of alluded to, there's a continuous life cycle here where feedback and a cycle occurs. So while the power profile standards have recently been completed, the 1588 standard itself is under revision, and as part of that, there is a security TLB that should be standardized ideally this year. It's technically complete for all intents and purposes at this point. And with NIST support, UNH-IOL has been developing a BSD-licensed early implementation of this capability. And what that really provides is authentication and integrity checking of the PTP timing messages. So while things like GPS could be readily spoofed, the wired network and the messages being passed on it could be hardened even further from malicious assault on the timing network.
Yeah, with that said, for us, if we can get our timing from within versus relying on GPS clocks, it gives us a much better feeling that we are synchronized at least to ourselves versus an external system that we could validate against, but no longer relying on it as a primary synchronization source like we do today.
Perfect. I think you actually answered one of these other questions that came through where somebody was actually asking why is GPS used over long distance and kind of more reliable method be used like carrier signals, and I think you guys answered that. Let's see here. We have another question for Kuhn, more specifically related to this ICAP effort. And maybe you could speak a little bit more about this, Kuhn, because you touched on a little bit in your slides, but currently is the ICAP program focused solely on conformity, and is there interest in moving towards interoperability aspect or feature of the program?
Yes, thank you, Jason. So I think both myself and Bob touch on that topic. We want to focus this program first for conformity conformant aspect, but we want to push for the full interoperability testing, of the both 1588 and other programs that want to put forward. So I think that's one of our goal to trying to push for interoperability testing, but like I mentioned before, it is a more difficult aspect than just the conformant piece, but we want to have interoperability testing. And I think through the ICAP effort, right now the current active program are on conformance testing, but we have to see how we can develop it into a interoperability test kind of program. But in order for us to kick off this conformant test program, we didn't want to blur that. We want to just focus on conformant at this time. But going forward, we do want to push forward with the interoperability testing and certification.
Absolutely. Okay. Bob, this might be a question for you. Do you see systems transitioning to hybrid IRIG-B PTP implementation?
From my perspective, it's certainly possible. Obviously, one of the advantages PTP provides is in-band timing. You don't need to have a separate dedicated and precisely measured cables or such for a network, but there is, as Aaron alluded to, existing infrastructure and things that may be connected with IRIG-B may not be removed from a substation anytime soon. But providing time up to a boundary device, a gateway, if you will, to IRIG-B certainly is conceivable, and there are several products that do such things today. I don't know if Aaron or others have further comment on that.
I'm sorry, can you repeat the question?
Yeah, so the question was, do you see systems transitioning to hybrid IRIG-B/PTP implementation?
Yes, because there's a number of products out there that only support IRIG-B input into them right now on the market. So those products have been going out in the last 5 years. It's only been recently the end products, and when I say recently, within the last year, have manufacturers provided the 2011 power profile of the precision time protocol. And so within the last 5 years, we have products that are using IRIG-B, and those will be on a system anywhere between 10 and the next 20 years. So yes, to answer your question.
Okay. Awesome. I want to answer a question very quickly. We have one I think I would be best suited to answer at least the first part of it. Somebody was asking about what's ICAP's involvement with NASB, the North American PHASOR initiative. This is obviously a little bit divergent from this conversation, but Aaron did mention PMUs and their applicability for precision time, and ICAP actually does have a program based around the C37.118 standard for PMUs and a certification program for that. And ICAP is very involved in NASB. We attend most of their meetings as a sponsor and stay current with all of their work, and hopefully we support their work and they support ours. As far as Kuhn, you have some involvement with NASB, correct?
So actually, there are other folks at NIST that are also involved in NASB. I know Jerry Fitzpatrick and Alan Goldstein from our electric metrology group actually is very heavily involved in NASB. So, and I think Yashan is also involved in the NASB effort as well. So yes, we're very much coordinated with NASB.
Mm-hmm. Mm-hmm. And Bob, have you been involved with NASB at all, or?
I participated in some workshops with a few folks, but I think NIST has been on the lead with this, as Kuhn just addressed. Yeah,
absolutely. So yeah, if anybody has further questions about ICAP's SynchroPHASOR program, and Tyler, actually, maybe you could advance the slide so everybody could get our emails. Yeah, if anybody has any further questions about SynchroPHASORs, please feel free to reach out to me. Also on the screen, as you can see, we have Kuhn and Bob and Aaron's contact information, who've all informed me that they are more than willing to answer your questions privately offline. So if anybody would like to reach out to them privately, please feel free to do so. We have two more quick questions here, and I think we might be able to end early, but the first one is for Bob. Bob, could you maybe clarify for the pilot program for people, what type of products is the pilot program actually looking for?
Yeah, it's a good clarification. We're principally focused on the network infrastructure, delivering time accurately to the slave device. So the grandmasters, boundary clocks, and transparent clocks are the principal focus. There are some aspects of a slave device that can be tested, especially if a 1 PPS is provided, but we're not going beyond the current power profile definitions. So much of the focus really is on the implementations of the networking infrastructure, the time transfer and the time inaccuracy as it's reported by the TLD, so named, to the slave devices.
Okay, good, thank you. And then Aaron, this might be sort of a difficult question to answer right now, but maybe you could speak generally. But something such as the IEEE 1588 Conformity Assessment Program, do you foresee BPA requiring such a certification in the future, or possibly other utilities?
As for BPA, yes. Yes, this is something that we can point to, that a device has been certified. It gives us a starting point, knowing that a device has been tested towards this standard, saving us a lot of in-house testing and verification. which again reduces the time to adopt the newer technology, the more reliable technology. So yes, when we can ask for or know that a device has been at least certified, then we can branch out to it's easier to apply. Does that answer your question?
Yeah.
With less testing on our part.
Sure. Yeah, I mean, I think it answered it, and I appreciate your response. Obviously, Aaron has been very involved with this ICAP effort and the 1588 standard, so clearly BPA has interest in pursuing something like this. So, okay. With that being said, everybody, we are a little bit early, but I know everyone's time is precious, and we all have important things to get to. So with that being said, I would just like to thank everybody for attending and hearing about this effort that IEEE is putting together. And I would also like to thank the presenters for their time and effort putting this together. We've had multiple coordination calls and a dry run to make sure this goes smoothly, and I think for the most part that it did. So thank you all for attending and joining, and I'm available if anybody would like to reach out, as well as the other presenters, and I look forward to speaking to you all in the future. Thank you.